problem, time needed to buy tickets. It's a queue based problem, but if you solve with queue, the time complexity will be higher. But once you come up with the queue solution, you can write a linear solution. Just give a thought to this problem. If you still feel difficult to solve, then I can explain. Today we will start with breadth first search. Let's see how it works. So let me explain. Yeah. So let me explain how breadth first search works. So this is you can hear me, right?
Yes. Recording is on?
Yeah, it is on. So let's understand how breadth first search works. So actually, it's a concept of levels. For example, I am at level 0, and as part of level 0, I will try to pick up couple of elements, and we can call it as level 1, and this is called level 2. And once you process level 2 can generate couple of elements which can be picked by the which can be used in level 3. So something like that. So we call it as level 3. So and so on. So you process the current level, and in the same order you process the current level, and as part of processing the current level, you can accumulate elements for the next levels. So this is how the concept of breadth first search works. Simple. So what you do, so you will add elements to the queue, and so at this point in time, for example, if you speak conceptually, so this is how it should be, right? So right now, when you are at level one, so when you are at level one, your queue will have only one element. Now you process the level 1 from the queue. So this level 1 is trying, when you process elements at level 1, as part of processing the elements at level 1, this level 1 is adding couple of elements. Let's say E1, E2, E3. So these three elements were added. So when you are trying to process level 1 from the queue, so this is your queue. So first you start with the starting level, and you pick up that element from the queue. Then you get the associated connections. Let's assume this node will have connected with other three nodes, so which is representing some couple of elements. So again you add those elements to the queue. Now as part of level 2, so this is my level 2. So I have three elements in the queue. So first I pick up element 1, and it is trying to add couple of elements to the queue. So let's say it is E1 dash E dash 1, so E1 dash 2, E1 dash 3. Similarly, I can process second element. Second element will add couple of three elements. Let's see E2 dash 1, E2 dash 2, and so on. Similarly, for E3 elements also, it will add couple of elements. So it will add these elements, whatever elements you keep on adding on to the queue, so which are going to be processed in upcoming levels. So it's a conceptual understanding, but when we solve the problem, you can easily tackle this. Hope you get the concept, right? Kalyan, Maithili. Concept is clear, Maithili. Okay. So let's move on. So this is the problem statement which was given. So actually you will be given a grid. The grid is having, let's say you will be given a grid. So this is my grid. Uh, so which is of length m by n. So you have a grid. Let's say 1 1 1 and 1 1 0 and 1 0 1. So you will be given a grid. So this is our grid. So what the problem statement says, you will be given a grid as an input, and row number and column number. So this is representing cell. Okay, and you are also giving a color. Color is represented by an integer value. So for example, so in this case, let's say this is my grid, and this is the row and column. So let's say this is belonging to row 1 and column 1, so 1 comma 1, and color, this is the value, so which is 1. So sorry, he is giving a color as 2. Let's say color as 2. So this color is represented by an integer value. It can be any integer. So let's say he is giving 2 as a color. What we need to do is go on to this cell. Okay, so I get into this cell. Then you can connect this cell vertically or horizontally. So this cell can be connected to, if you closely see on the problem statement, somewhere it has written. So yeah, if you closely see, this cell is connected to either horizontally or vertically. So this cell is connected to adjacent cells vertically or horizontally. So this is horizontal and this is vertical. So this is connected to vertically or horizontally. So what the problem statement says, go to the grid, pick up that cell, and within that cell, what is the value you have? So I have a value 1 here. So I have a value 1 here. So when you connect these cells vertically or horizontally, whichever cells having value 1, replace those values with the given value, so which is 2. So in this case, if you closely see, this is how it should be. So let me redraw the diagram. So I have 1 1 1 1 1 0 and 1 0 1. So this is the grade which was given. So this is the cell which was given. So if I connect from here, this cell, this cell, because 1 comma 1 is represented by this cell, so which is connected to vertically horizontally. So this one and this one and this one. So first we need to change all the connected cells which are having value as 1 to be changed to color given in the form of input. So the color is represented by integer. Here it was 2. So all the connected cells I can change to 2. Okay, fine. So let me do that. So 1 2 yeah, so 1 2 1 and 1, so 0. Okay, so the connected cells, right? So again this will become 2 and this will become 2 and this will remain same, or let me adjust the same input so that things will be clearer. So you have connected, right? So these are the connected cells. So when we connect vertically, I have value 1, so which is same as grid cell value, so it changes to 2. When I move to right, so this is having value 0, which is not same as 1, so that you don't need to change. To the left I will change, and to the bottom also I have 0, so there is no change. Now if you closely see, this is what at first level, so at first level this is what the output I got. So 1 2 1 2, you can change this to 2 because you will obviously update that, and 2 to 0 and 1 0 1. Now what he's trying to say is you need to continue this process until there are no adjacent connections having the same value as 1. So for initially at first level, if you closely see at level 1, so when I make a connection, so I found 3 ones, 2 ones, those 2 ones were updated to 2. Now if you closely see, these are the cells, right? So these are the cells again, so that I need to make a connection between them, so that this is also, this process will continue unless there are no elements to process. So when I connect these two, so if you closely see, as part of level 1 these two were updated to 2. As part of level 2 I have two elements, so this one and this one. So if I make a connection, so vertical and horizontal connections, I could find all other ones, so that if I update those values, so this is how it should be. So 2 2 2, because this is updated to 2, this will also updated to 2, and again you will have 2. So anyhow the top one is updated to 2 and there is no change here, and here the bottom one is 1, so which will be updated to 2, and 0 and 1. Now if you closely see the newly added cells, right? So the newly added cells were this one and this one and this one, right? So these are the newly added cells, because earlier it was having values as 1, but now we updated to 2 as per the problem statement. Now if you make a connection, right, if you make a connection to the newly added cells, so there are no elements to process. If you find a value as 1, you can update that value to 2, but all these newly added cells, newly added values doesn't have any other connections which is having value as 1. in order to update it to 2, so that obviously you stop the process here. So this is what the expected output. Do you understand the problem statement? That's what the problem statement says. So if you closely see, so this is what is trying to say. Maithili or Kalyan, is the problem statement is clear so that we can think about how to solve this. Yeah. Okay, so let's move on. It's a very good problem on breadth first search. So first let's move on how to tackle this. So let's say you have elements as 1, 1, 1 and 1, 1, 0 and 1, 0, 1. Okay. So these are the elements given. So he has given grade and row number as 1, column number as 1 and color as 2. It means get into this row column and take this value, whichever connected cell having this value, update that value to 2. That's it. Now if you closely see, here I am. So this is 0, 1, 2 and this is also 0, 1, 2. These are the columns and these are the rows. Okay, now let's move on. I am at 0, so he has given cell 1 comma 1. Okay, so I has given cell 1 comma 1. So when he has given cell 1 comma 1, so I need to make a connection to the left, right, top and bottom, so vertical and horizontal. If I go right, it means you are just, if you see, if I go right, what are you doing? You are on the same row, you are just incrementing the column, correct nobody? Yes or no? So right is equal to 1 comma 2, right? So if you go right, so what is the cell you will get? So the row becomes same, but the column will be incremented by 1. If you go left, the row becomes same, the column will be decremented by 1, because when you move left, so this is how it should be. So when you move left on the same row, 1 comma 0, here 1 comma 1, here it is 1 comma 2. That's it. So similarly, if you go up, what is happening? So the row, if you go up, the column becomes same, but the row will be decremented. So you are here. So when you go up, so it will be 0 comma 1. It is 1 comma 1 earlier. So when you go up, so the row will be -1 and column will remain same. So that obviously this is how it should be. So it is going to be 0 comma 1. If you go down, so you just increment the row, column remains the same. Now let's see what are the values present in it. So what we are trying to do, so this is my level 1. So I am at level 1. So what I am trying to do, so I am having Q. Okay, so before getting into Q, let's solve this with conceptually, then we will get into Q. So I am at level 1. So this is my 1 comma 1 cell and I am trying to process this cell. But if I see adjacent connections, these are the adjacent connections I have, but I understand that this is having value 0, this is having value 1, this is also having value 0 and this is having value 1. Now it's time for me to pick up the valid cells. What are the valid cells? So this one and this one, these two are the valid cells, because other directions are not valid cells, because those are not having the value as 1. Okay, so what is my job now? So whichever I could find or valid cells, I will mark them. I will update those values to 2. So I'll update this value to 2 and this value also 2, and current cell obviously this will become 2. Now more importantly, whenever you find a valid cell, how do you find a valid cell? So the cell should be valid and the value should be equivalent to whatever input value, whatever value present in this grid. Okay, so I found two valid values. So when you find two valid values, so that you need to start the process, right? It's time to update those two values. So you updated those two cells, perfect. So you updated those two cells, values will be 2 comma 2, and we need to continue the process for the latest two cells. So we need to add those two cells into the queue. So one is 1 comma 0, other cell is 0 comma 1. Closely understand, we have started a queue with 1 comma 1. So this is my level 1. Okay, so we have started a queue with 1 comma 1. So this is my level 1. Okay, so 1 comma 1. So this is my level 1. So through level 1, when I try to apply the requirement, I understand that I found two valid cells. I updated the value And for level 2 I have added these two cells into the queue. Now it's time for me to process these two cells. So in the two cells, so first let me draw here. So you have the updated diagram as like this. So 1 2 1 and 2 2 0 and 1 0 1. Okay, so let's move on. So now our requirement is these are the two cells which are newly added. So let me try to process this cell. So okay, so when I go top, when I go down, when I go left, right, when I go left. So when I come left, obviously this is going to be what? 1 comma minus 1, because it is 1 comma 0 minus 1 means 1 comma minus 1. This is invalid. When I go right, if you closely see, this cell is already, so obviously you already updated the value, right? So you have already updated the value so that it is having value 2, but expected value is 1, so that this is also invalid. You don't need to maintain separate visited kind of thing, because as you are updating your value, so you are keep on checking the data based on having value as 1. So when I go top, I found value 1, so it's time for me to update this value to 2. Then take this cell. So what is the cell? It is 0 comma 0. And when I go down, I found valid value 1, so update this value to 2. Again take this cell. So the cell is what is this cell? So it is going to be 2 comma 1. Done. It means 1 comma 0, 1 comma 0 you are trying to process, you are trying to take out 1 comma 0, and you taken the adjacent connections of 1 comma 0. So these are going to be next process. Next time you will process those elements. It means at level 1 you have only one element in the queue. At level 2 you have two elements in the queue. So first you processed one element. Let's process the other element. So 0 comma 1. So this is 0 comma 1 cell. So go down, go left, go top, go right. So when you go left, already value updated to 2, so that this won't be considered. When you go down, this is also updated to 2, so you don't consider. When you go top, obviously which is going to be minus 1 comma 1, so which is negative, so that you don't consider this. But when you go right, you see that there is a value 1. Now value 1, so that's why what you should do, first you update this value to 2. Perfect. So once you update this, then add that value to the queue. So the value is going to be 0 comma 2. Perfect. So now if you closely see, in the previous level I have two elements. I have processed those two elements. As part of processing those two elements, for the first element I found two elements, for the second element I found one element, and this is going to be my next level. So for the next level I need to process these three elements. Now if you closely see, by this time if you closely see, this is how my input could be, right? So 2 2 2 and 2 2 0 and 2 0 1. So this is my input, because we have already updated all the values. Now what are the new values which were being added? If you closely see, the new values are 0 comma 0 and 2 comma 1 and 2 comma 2. So these are the new values which are to be processed for the next level. But if you closely see, when you go left, right or top, anytime for any cell, if you closely see, for this cell, when you go right, you found value 2, so which is already updated. Down you found value 2, which is already updated. Top is invalid, left is invalid, so that as part of processing this cell, none of the element will be added to the queue. Now when I go on to the next cell, so this one, so 2 comma 1, so when I go right, it is 0, so that you don't need to add. When you go top, which is already updated, when you go left and bottom, so those are invalid cells, so that as part of this cell you don't find any data. Now when you come here, so bottom, left, right, top, same situation, so there are no elements to process. Now you see, when you process level 3, so there are no elements on the queue, and you didn't add any other elements to elements 2, so that your queue becomes empty. It means you are done with the process. So if you see the completed updated array, so this is how it should look like. Do you understand the concept, Maithili, Kalyan?
Yes.
Maithili, is it clear?
Yes, yes.
Right. So what is the time complexity here? So first of all, we need to see four directions, right? So I am at here. So if I want to go right, so there is no change in row, but there is a change in column. So you just add +1 to the column. So if you want to go left, say rows remain same, my column will be decremented, it is -1. If I want to come down, so column remains same. We need to increment the row so that 1 comma 0, right? So hope you are able to understand, right? So this is how it should be now. So I am at this cell. So let's say this is represented as row comma column. If I want to go right, so row remains same, column will be 1. So I can represent this as 0 comma 1. And if I want to go left, row remains same, column will be minus 1, so that I can represent it as 0 comma minus 1. If I want to come down, column will remain same and the row will be incremented, so row plus 1 comma column, so it means 1 comma 0. If I want to go up, so it is going to be minus 1 comma 0, so we just need to decrement the row, column remains same. So these are the directions we have. So because it is saying vertically, horizontally, so that we need to pick up 4 directions. So this is right, this is down, this is left, and this is top. Perfect. So what is the time complexity? If you closely see, what is the time complexity here? What is the time complexity here?
It will be m by n.
It's really,
That's it, right?
you
It
know,
should be m by n, right? So there are
I mean,
no additional things we are doing. So we are in worst case we visit all the cells. Maybe sometimes same cell will be visited twice, so it can be 2mn, but you can consider it as m by n. So what is our job? So first, this is how it should be, right? First we pick up 1 comma 1 cell, then we move on to the next level. So when we move on to the next level, so these are the 2 cells we can cover. So what are the 2 cells? So this is top you have 0 comma 1, left you have 1 comma 0. So this is level 1, this is level 2. Now in level 2 we need to process these 2 cells. So when you process these 2 cells, somehow you could end up having, so let's say you consider this one. So obviously you will update this to 2, this will be 2, this will be 2. Then in level 2 you are trying to process 0 1, so let's say 0 1. As part of 0 1, so this is 0, okay, so this is 0 1. So as part of 0 1, so you will go left and right, so top and bottom. So bottom you already updated the data. So as part of 0 1, you have added 2 cells, one is 0 comma 0, another one is 0 comma 2. Now this will be updated to 2, this will be updated to 2. Now when you come here, so it is 1 comma 0. So when you go up, there are no elements to add. Right, left, and bottom you found an element. So as part of this element you updated the value as 2 comma 0. Perfect. So you just update, that's it. So as part of level 2 you have added 3 elements for level 3. So when you are doing this, so when you visit, all the cells were already been updated, so this will add nothing, this will add nothing, this will add nothing. So simply your queue becomes empty. Clear na? Clear na, buddy? This is how it should be, right? So in
Yes.
worst case you visit every cell twice, so the time complexity is going to be big O of mn. And what is the space complexity? What is the space complexity?
We are adding all the elements to the queue, right? The worst case if all are ones.
Even all are ones, so then what you do? You will add only 4 elements, right? Then other 4 elements will add next level of elements, right? So if you consider this as a full binary tree, something like this, so you have 2 elements and you have 8 elements here. If you consider it as a full binary tree, in a queue at max you have n by 2 elements. Okay, so let's take mn as n. At max in a queue you will have n by 2 elements. So big O of mn by 2 in this case, but you can consider as big O of mn. Is that clear? Kalyan, Maithili, Akash.
Yes.
Okay, so let's move on. Mn by 2, so you can say it as big O of m. Yeah. So let's implement this code. Okay, so what are the things we need to consider? So first thing is, first you will add whatever element which was given. So he is giving row and column, right? You will add that element to the queue. Then you only process that element. Okay, for the current level you only process that element. That's it. And to the next level, when you are processing these elements, you will get three elements again. For this level, you process these two elements. Okay. Okay, so you process these two elements and so on. But actually in this case, it doesn't matter. It doesn't matter whether you need to process only those elements or not. It doesn't matter. Why? Because he's not expecting any information specific to level level processing, so that you can blindly focus on basic queue logic and update everything. So let's do that how it could be. So one thing is you have queue, so you can consider it as integer array, which is representing row and column. So it's up to you how do you want to go with. So you have a queue, so new linked list. Okay, so what is our job? First we need to add first cell to the queue. So queue dot add of new integer array of this source and this, whatever source you have, whatever column you have, we just add it. So just consider this value. So what is the value? So let's take this value as x, or let's consider anything b, so which is presented in the grid. So it is image of source comma source row, source column. So what is our job? First we need to update. We taken the previous value and we'll update this value to color. So whatever color he has given, so we will update. So that's it. So now if you closely see, our queue is having the first level of element. Now it's time for us to process the data. So while, as long as your queue is not empty, so we need to process the data. So let's move on. So first we take the current cell. Okay, so we will take the current cell. So cell, you can say queue dot pool. You will get the current cell. So once you get the cell, so you can get the row, cell of 0 you can say, and column which is going to be cell of 1. Okay, so you have row and column. Now you need to see all four directions. So let's do that. So directions I can just mention in the form of two-dimensional array. So these are the directions. So as we know that, so this is our directions, right? So new integer array. So as you know that, so one is right, other is left. So only change in column, and other is bottom. So change in row, and up. So change in row. So we just decrement the row. So these are the directions. Hope you understand this. So once you have the directions, now it's time for us to calculate the directions for this cell. So you will have integer array, and this is my direction from directions, and you can calculate the directed row. So which is going to be row plus dir of 0, and directed column which is equal to column plus dir of 1. Okay, so we get a directed row and directed column. Now it's time for us to find out valid things. So first we will see if this is valid. So when you're at 0th row, if you go left or if you go top, the row becomes negative, so that you can say it is if row less than 0, directed row less than 0, or directed column less than 0, or when you come down, your row can reach to the last row, so that if directed row is equal to image dot length, or directed column is equal to image of 0 dot length, so which is our column length. So if this is the case, you can ignore, or so whatever value. So what are we trying to do? So whenever we are trying to process it, right, so what are we trying to do? We figure out whatever value which is equivalent to cell value, right? So when you move on to the direction, so whatever value which is equivalent to cell value, so we consider only those cells. So we need to check that condition too. So what is other job? If everything is valid, then whatever cell value, image of directed row, directed column, if it is not equal to the given value, so this is the source value, right? So you can say sv, I can say, so this is the source value. If it is not equal to source value, then it's, we understand that this is invalid cell. So if it is invalid cell, so we will just continue. Otherwise, what is our job? We pick up this cell. Okay, so we pick up this cell, then we will just update whatever value the input has given. So we will update the value. Then it's time for us to add this row and column to the queue. So this is my queue. So queue dot add, so new integer array of add this directed row and directed column. Is this clear? That's it. So this is the code. Is this clear, everybody? So what we did, so we have taken four directions. So left, so one is right, left, top and bottom. This is my queue. I am starting with source SC and SR, so sorry, source row and source column, and I have added to the queue. I copied the existing value and we updated the source row source column value with the given color. Then we will pull the current cell and we get the row and cell, and we try to figure out all four directions, so the four directions mentioned here, and so we'll just get the directed row and directed column. So if it is invalid, when it is invalid, if the directed row less than 0 or directed column less than 0, why? Because if you are at 0 0 cell, right, if you are at 0 0 cell, if you go left, what will happen? It becomes 0 comma minus 1. So it means the column becomes negative. Similarly, if you are at 0 0 cell, if you go up, then definitely it is going to be minus 1 comma 0. So that's how it should be. Similarly, when you are at last column, if you go right, it is equivalent to length. So if the directed row is equivalent to image row length, or directed column is equivalent to column length, or if directed row directed column value is not equal to the source value, so whatever, because we need to update only those values, right? If it is not equal to source value, so we simply continue. Otherwise, we take up the cell and update with the given value in the input. Then we add that cell to the queue so that it will be processed for the next iteration. So that's it. That's how the BFS works here. So finally we can return same image. Is that clear? Kalyan, Maithili?
Yes.
Yes, that's it. So we will just run. Is there anything wrong? Time limit exceeded. So let's see what is the wrong we did. We pull this and this is not at all going empty. So let's see what is the mistake we did. We update to color. That's it. So it should work. Why is Q not becoming empty? Let me print Q here. So 1, 2, 4. It's keep on increasing the queue size. Why it is not going? Why this is not being updated? 1 1 2. Perfect. Source value, that's perfect. We are updating to color and we just added to the queue. Why the same cell is keep on visiting again and again? Why this is 0? Is there any mistake here? I don't see any issue. Why this is always coming as 0? 1 0 0, 2 3 zeros. Okay. I understood. So the problem is we just compared with not equal to SV. That's correct. Uh, when you are here, the 0 not equal to SV, so that you just continue, but why it came down? Uh, what is the SV value we have? Okay, this fellow, okay, it was failing for different test case. Actually, we tried for other test case. Uh, it was failing for different test case. He has given source 0, column 0, and color also 0. So that's why it is failing. So I think for this test case, it is failing. Let me. So for this test case, it was passing. So I think we have missed it. He was trying to add all zeros. Okay. Source and column, everything is 0. So it's a good test case. And he is giving this as 0 and column as 0. And this is also 0. So what is happening? It's getting into loop. It's keep on adding same elements. Okay. Color also same and value also same. Then we end up keep on adding the same cell again and again. Do you understand the issue? So it is working for this test case. And what he's trying to do, he was given a very critical test case. So you have all zeros in the all zeros as a cell. So source also 0, column also 0, sorry, 0 0 cell. The value itself is 0 and color is also 0. That's why it is going in loop. So what we should do, one way is we can maintain visited array, so that if it is already visited we can just simply ignore it. Yeah, so let me do that. Boolean, this is our visited array, so you can say visited new boolean. Yeah, so we can take up the same row length. So this is my row length. Do you understand the issue now? Did you get the issue, why it is getting into time limit exceeded? Kalyan? So in the test case, what he has given, all are zeros.
Yeah.
So of course, the given value is 0 and replaceable value also 0. Then it will end up into loop, right? In this test case, the given value is 1, replaceable value is 2, so that you don't revisit the same cell again and again if you compare with the value. Understand, Maithili?
Not that clear.
Okay, so
I'll try to revisit more.
okay, so let me explain, no problem. So what he is trying to do, so you have so you have 0 0 0 and 0 0 0, and he has given 0 0 as a cell, and color you wanted to replace with 0. So now let's say you replace with 0, and actually when you go left and right and you found same value, right, and you find that this is valid values. So this is valued values, you replace with again 0, and when you go left and top and again you see that this is valid value, because you are looking for 0, you already have 0 here, and again it will be added to the queue.
Yeah.
So that's how you end up looping into the same thing. So that's why what we should do, so what we should do, one way is we can yeah, so if it is not equal to sv, one way, this is of course you can use visited array. Other way is, if it is not equal to sv, or if it is already having same value, so which is color. So if it is having same value, so you don't need to add it to the cell, so you can simply run it. So that's only the case. Let me see, does it cause any issue or not? Let me run. Yeah, that's it. So this is only the condition. So what is happening, he was given very critical test case, so it is ending up into loop. So if you add that condition, it will work out. Clear? So what is other way? The other way is you can maintain a visited boolean array. So once you add that to the image, that to the queue, you can mark that column as true in the visited boolean array. So next time you can simply rely on that visited boolean array mapping to the same image grid. Is that clear, Kalyan, Maithili?
I mean, whatever we visit, we mark them as true,
Yeah.
and adjacent items we'll add it into
So
adjacent
what I'm trying
column
to say,
into.
this one you understood, right? This logic
Yes.
you understood, right? Now
Yes.
what I'm trying to say is, the other way is you will get m as image dot length, right? So then n as image of 0 dot length. So now you are going to go with boolean array. We can call it as visited, and new boolean array of same length m. So by default it is false. So now if you closely see, when you come here, once you come here, so you can simply mark it as visited. So visited of this directed row and this directed column as true. Now whenever you see here, so you can say that if it is already visited, if the directed row and directed column is already visited, you can simply continue. Is that clear, Maithili?
Yeah.
Yes.
Yeah, so that's another way. So you can do the same thing, but it is taking additional space. This one mn space. The other logic we have written that doesn't take mn space. Okay, so okay, so with this knowledge, let's try to solve this problem so that you will get good idea on BFS. Okay, so this will definitely need a level processing. So what he's trying to say, you will be given a grid. So a grid having either of the three values. One is 0 or 1 or 2. 0 representing empty cell, 1 representing fresh orange, 2 representing rotten orange. So what will happen every minute any fresh orange that is four directionally connected to rotten orange becomes rotten. So what he wanted to tell us is return the minimum number of minutes that must elapse until no cell has a fresh orange. If any cell has fresh orange, you can return -1. So let me explain. So this is what he is trying to say. So you have given input as, so you have given input as 2 1 1 and 1 1 0 and 0 1 1. So he is saying in the problem statement, if you closely see, in the problem statement he is saying 2 representing rotten orange, 1 representing fresh orange, 0 representing empty cell. And every minute a fresh orange that is four directionally connected adjacent to rotten orange will become rotten. So we need to return minimum number of minutes that must elapse until no cell has fresh orange, otherwise return -1. So let's look into this. So you have, so if you closely see, you have rotten orange here. 2 is representing rotten orange, so which is four directionally connected. So it is connected to these two cells. Now, so every minute, whenever rotten orange four directionally connected to fresh orange, those will become rotten. So it means this is the first minute. So this is minute 1. So in minute 1 what will happen, whatever directly connected, those becomes rotten. So if you closely see, this becomes 2 and this will also becomes 2. Now you have 2 2. Now again if you closely see, you have next row, and you have 2 2 1 2 1 0 and 0 1 1. Now if you closely see, these are the new cells, right? So these are the new cells which were added at previous level. So in the second minute, so this is four directionally connected, and of course this is also same. uh, Let me draw valid directions only so that we don't need to make it clumsy. Yeah, so if you closely see, this is four directionally connected. So when it connects to left, obviously which is rotate, so there is no change. Top, there is no change. So if you closely see, and this will also connected four directionally. So but if you closely see, the bottom will have 0. So this is not fresh orange, so that this will become 2 and this will also become 2. So in the second minute, if you closely see, these are the two fresh oranges will get rotten. So this one and this one, other one were already done. So in the second minute, this will be done, this will be rotten. So this is minute 2. So let's move on. So for minute 3, so what will happen? So for minute 3, so this is going to be the fresh list, right? So now if you closely see, this is my fresh list. So you have 2 2 2 and 2 2 0 and 0 1 1. So these are my fresh list. If you closely see, so these are the two oranges which were added, which were rotten recently. So this one will get rotten, obviously, because to the right, top, left and bottom, all there are no valid results. So this will get rotten. Now this is minute 3. Now if I go further minute, so this is how it should be. So we will have 2 2 2 and 2 2 0 and 0 2 1, and this is for minute 4. So for minute 4, so what will happen? So there is only one roten orange which is connected to fresh orange. So this will get roten. That's it. So we just need to return answer as 4. Is the problem statement clear? Maithili Kalyan.
Yes.
Maithili, is it clear?
Yeah.
Or is it confusing?
No, actually, like I have issues with 2D array. Like I get confused, but I think I'll follow as we progress further.
Yeah, so if you closely see here, he has given very good analogy. So let me copy this. Control Shift 4. Let it load. Okay. Yeah, if you closely see, so this is what, right? So initially we have one roten orange, so which is connected to these two oranges, fresh oranges. So these two got roten now. In the minute one, these two got roten. Then what will happen? Yeah, so this is connected to these two, so these two got roten. So now in the next level, so this will be connected to other fresh oranges, so this will got roten. Now in the next minute, so this is connected to this one, so that this will got roten. In the next minute, this is connected to this one, so this will got roten, so that we need to return minute 4. So this is the problem statement. Now let's see how do you solve this. It's a pure BFS problem. Now if you see the other example, if you see other example, let's say 2 1 1 and 0 1 1 and 1 0 1. Okay, so let me take this. Okay, so let me copy this. Okay, so if you closely see this one, right, so this is connected to these two, so that obviously this will get roten, so that by this time, so this will get roten. So this is minute 1, this is first minute. In the second minute, if you closely see, this is the freshly oranged or freshly added orange, right? So this is connected to this one and this one, so that these two will get roten. So it means here it is 2, so which is connected to this one and this one, so these two will get roten. It's 2 and 2, so I just add 2 and 2 here. Now this is minute 3. So in minute 3, so what will happen? Don't get confused. Hope you are able to follow me, right? So this is from here I am starting. So I go right and I go down, I go top, I go left. So there is only one orange will get roten. So this one. So it means for the first minute, so this one get roten. So this is for second minute. So for second minute, you already have 2 here. So you already have 2 here. So now this is going to corrupt other 2 fresh oranges. So this one and this one, so that this will be 2 and this will also be 2. Now in the second minute, so this is how it should be. This is already 2. The fresh oranges which were roten are this one and this one. So in the third minute, so these 2 roten oranges will roten this one and this one, and there are no others. If you closely see, there are no other oranges to be roten, so that obviously this is already 2, this is 2, and this will become 2 and this will become 2. Now if you closely see, when you process this, right, yeah, so closely see, better I'll write. So this is the result you got, right? So the result you got as 2 2. So this is the fresh orange, so which gets into roten, and you will have 0 2 and yeah, this is a fresh orange which got roten in previous step, and you have 1 and 1 0 1. Okay, now if you closely see, these two are the fresh oranges, so which is connected to this, which is connected to this, so only this is the one which is going to be roten, so this will become 2. Now if I closely draw this diagram, so you have 2 2 2 0 2 and 1 0 1, and you have one fresh orange which gets into roten. Now if you closely see, this is connected to this, so this will get roten. Now to the next step, if you closely see in the next step, so this is how it should be. Let me copy this. So in the next step, so if you closely see, this was the fresh orange, this remains same, so this is going to be the fresh orange. Now this is connected to 4 directions, but I don't find any, this is the roten orange, I don't find any fresh orange, so that you don't do anything. So but if you closely see this left, right, there is one fresh orange which is left in grid, so in that case you just need to return -1. So that's a second test case, that's what he is trying to say. Return, so you see, return the minimum number of minutes that must elapse until no cell has fresh orange. If this is impossible, return -1. So in this case, this gets into -1. So this is not roten, so that we need to return -1. Now let's understand how do you tackle this, right? It's a very good problem on BFS. Is it okay to continue, or do you want to listen tomorrow? Kalyan?
Yeah, we can.
Okay, so let me do that. So simple. It's a it's a very good problem on BFS, but this will need, right. So this will need level processing. So in each minute. So let's see. Let me get into that. So first, let's calculate how many fresh oranges you have. So how many fresh oranges I have total? 5, right? Correct, na? There are total 6, right? 6 fresh oranges. 1, 2, 3, 4, 5, 6.
Six.
Okay, so now what I will do, I have total 6 fresh oranges, fine, total 6. Okay, now what is my job? First I will traverse this complete list. Okay, I will traverse this complete list and complete grid. I will add the oranges which are roten into the queue. Okay, so I'll add the oranges which are roten into the queue. So at 0 0 cell I have an orange which is being roten, so that definitely I will have 0 0 cell to the queue. This is my first level, correct now? This is my first level, so as per this input I have only one roten, so this is my first level. So for the first minute, this is connected to, what are the valid cells? If you closely see, this is connected to, so this is connected to this one, and top and left I see this 0 1 cell, right? So this is 0 1 cell, so which is having the valid value, so which is having fresh orange. So that what I can do, as part of processing this level, as process of processing this level, what are the connected cells can be roten, I will add them to the queue. So this is my level 1. In this level 1 I need to process only one row, one cell, right? Because in the level 1 I have only one cell in the queue. So in the level 1 I have only one cell in the queue, so that I need to process that cell. As part of processing this cell, let's see what are the other cells you can add. So this one I can add because this is valid, so that in the queue I have 0 1. Okay, perfect. So I have 0 1 cell. Now if you closely see, there are no other valid cells. If I go bottom, it is an empty cell, left nothing, top nothing, only right I have valid cell. So I have marked this as, obviously whenever you are trying to add to the queue, first you mark this as 2. Perfect. Now you are at 0 1. Okay, so this is level 1, so it means within 1 minute, within minute, first minute, so this is my first minute, so within the first minute I am able to rotate this orange and I have been added to the queue. Now this is my level 2. So in the level 2, I have a cell 0, 1, so which is being written due to previous level. Now let's understand what are the valid cells I can add. I can add this one and this one. These are the two valid cells I can add. So I can add these two cells. So one is, so it means as part of process in level 2 also I have only one row I need to process. So I just need to process only this row, sorry, this cell. So let me process that cell. As part of processing that cell, if you closely see, I found two valid fresh oranges. So that those are what, so when if I go right, so which is going to be 0 comma 2. If I go down, so which is going to be 1 comma 1. Okay, so let me erase this. So let me add, so I found those two fresh oranges, so that let me add those two fresh oranges to the queue. So 0 comma 2, one is 1 comma 1. Okay, perfect. So as part of level 2, so you updated these two. So that's it. So it means for minute 2, closely understand. So in minute 2, these two got, these two oranges got uh, these two oranges got rotten. Now this is level 3. This is level 3. Now level 3, I am having two records. I need to process two records, because what is happening, so it is happening in parallel, right? In parallel, all the oranges gets rotated in parallel, right? So that you will consider all the elements on that particular level. So all these levels, right, whatever fresh oranges connected to all these cells will get rotated into single minute, right? That's why this is level 3. So for level 3, let's consider 0 2. Okay, so let's move on. So let's consider 0 2 cell. Perfect. So at 0 2 cell, what I am having, let's go there. This is my 0 2, right? So this is my 0 2 cell. So if you closely see, 0 2 cell can only connect, can only rotate this orange, because I could see only this one is the fresh orange. So that let me add. Okay, so let 0 2 cell can rotate, what is that, 1 comma 2 cell. Okay, perfect. So this is getting rotated. So then it means this is been processed. Now let me process this element. So when I get into 1 comma 1, now if you closely see, when I get into 1 comma 1, is the input is valid, 1 1. This is also 1, buddy. Yeah, this is also 1. Okay, this is also 1. I forgot to take this, but ideally this is 1. So as this is 1, ideally this will be processed as part of level 0 only, because you have right and bottom. So in the bottom you will have right, you have 0 1, bottom you have 1 comma 0, right? Hope you are able to follow me. Is that clear, buddy? I took invalid input, that's why. Is that clear?
Yes. Yes.
Okay, so let me update that. So or else it will return -1, so that is also fine. Let it be. Okay, it's fine. So for yeah, I process 0 1. When I process 1 comma 1, if you closely see, so 1 comma 1, so there is nothing, right? So if you closely see, there is nothing. All our already, all are either zeros or already roten, so that it doesn't add any element. Now let's move on to level 4. Okay, it means in the third minute, so this orange gets roten. So 1 comma 2, this orange gets roten. Now, so now I need to process this 1 comma 2. So when I process 1 comma 2, so this is at level 4. So let's move on to the next one. Sorry. Let's move on to the next one. So when I move on to the next one, if you closely see, this 1 comma 2, so which is 4 directionally connected. So if you closely see, this one and this one on top, I could see only this cell, so which is 2 comma 2. So this will upgrade this one to 2, so obviously which is 2 comma 2. So this is my, it means in the 4th minute, so this will get roten. Perfect. So now when I try to process, this is level 5. So when I try to process this element, so I understand that there are no valid cells, so that I can simply, this will get deleted, so that obviously your queue becomes empty. So each time you pop the value, so first what we did, so let me repeat. So first we started from 0 0. So 0 0 is added in the queue. As part of level 1, I pop this 0 0 cell, and I see all four directionally connected valid cells, and I understand that only this one is valid, so that I just added that to the queue. so that in the first minute I have updated this to row 10. So I went on to 0 2. Now I connected 4 directionally. I found two cells, so I was added those two cells. Now in the level 3 I just pop this, and I taken this 0 comma 2, this one, right? So 0 comma 2, and I just connected 4 directionally. I understand that only this one 1 comma 2 is the valid cell I have added. For 1 comma 1 there is no valid cell, so that it didn't add any result to the queue. So for level 4, so when I pop 1 comma 2, so see, when I pop 1 comma 2, I found 2, what is it, 1 comma 2. So I found 2 comma 2 is the valid cell. I just took that cell. Now as part of level 5 I don't find any other cell. So I don't find any other cell, so that your queue becomes empty. Now if you closely see, whenever you are adding the cell to the queue, it means you are trying to roten that orange, right? So you are trying to making sure that the fresh orange is getting roten. So let's see what are the cells you are trying to. So this is roten orange. If you see, these are the cells you added to the queue, right? So 1 2 3 4 5. So actually fresh oranges are 6, but you have updated only 5. 6 minus 5, because it is 1. It means the fresh oranges count is 1. So it means if it is 1 means you need to return minus 1. So the after processing the complete result, the fresh oranges count should be 0. If it is not 0, then you can return minus 1. If it is plus 1, if it is 0, then you can simply return the total minute count. Okay, so let me quickly go through the valid input, so that we can come up with the code. So this is what the input, right? So 211 and 110 and 011. Okay, so let's quickly move on. So initially you are having 00 in the queue. Okay, so and we know that total fresh oranges are 6. Okay, now let's move on. So which is connected to these two cells? Okay, so let me update quickly. So which is connected to these two cells? So it means this cell will get added, cell will get added. So obviously this will become 2, and this will become 2. So whenever you add a cell, so update the count here. So 1 5 and 4, fresh oranges becomes 4, and you are also adding those cells to the queue. Okay, let me add those cells to the queue. So one is 0 comma 1, other is 1 comma 0. Okay, so let's move on to, this is level 1 and this is level 2. Okay, so whenever you are processing the levels, so you will have minute. So when you are trying to process current level, so these are the oranges gets roten, so that here the minute count will be incremented by 1, so it becomes 1. Now let me process the first element 0 1. So 0 1, so this is 0 1, so which is connected to this guy and this guy. So 0 1 will add, sorry, so 0 1 will add two cells. So one is 0 comma 2, other is 1 comma 1. Perfect, so these two will get 2. So actually you updated two fresh oranges, right? So obviously here also you will update, so that it becomes 2. Now let's move on to 1 0. So this is 1 comma 0. So if you closely see on go right, left, top and left, so none of the cells are having fresh oranges, so this will not add up any data. So you will have this one. Now let's process this. So every time when you move on to the next level, so you keep on update the minute count. So for the first time the minute is 1, in the second time the minute is 2. Now you move on to third level, so the minute is going to be 3. So to the third level, if you closely see 0 2, right? So 0 2, so this is 0 2 cell, and it doesn't have any valid data, so that it will just end up with it. Now 1 1, if you closely see, this is 1 1. So 1 1 is having one valid cell, so which is 2 comma 1, so which is going to add 2 comma 1 cell to the grid. So this will update to by 1. So earlier it is 2, now it is becoming 1. Now this is here it is 1 minute 1, here minute 2, here minute 3. Now you are trying to process 2 1. Now when you process 2 1, so this is 2 1. So 2 1 is internally connected to this, and this is 2 comma 2. So you just process that. Once you process this, there are, when you process 2 comma 2, so there are no other elements to process, so that you just return. So you keep on update this minute, so that minute you can simply return minute. So if you closely see, in this case fresh oranges become 0, you can simply return 4. Is that clear, or did I went very quick?
Yeah, it's clear.
Maithili?
Yeah, actually, yeah.
You are not confident, Maithili. I made you confused or what?
No, no, this second time it's clear actually.
Okay, okay. So let me write the code, so that you can easily understood. Okay, so the first thing is fresh orange count. So initially, which is 0, and what else you can do? You can also end up having q. Okay, today the class went little long. Okay, so this is my linked list. So what is my job? First, I will find all the rotten oranges. So let's take m as grid dot length, n as grid of 0 dot length. So what I will do first, I will start from 0, and where is it? Row less than m, row plus plus. Similarly, column 0, column less than n, column plus plus. So now there are a couple of things I need to consider. If the current grid row column which is equal to, it means it is roten orange, so that it is part of level 0, so that I will just add to the queue. So q dot add of new integer of row comma column. So this I will add, that's it. Other else if grid of row column equal to 1 is equal to 1, so I'll just update the fresh orange count. So this will just give up all the data which is needed to start with the BFS process. So once you are done with it, now it's time for us to process the BFS. So this is very important. So one thing for sure, so we can say if fresh orange count is equal to 0, so it means you can blindly return 0, because there are no fresh oranges to roten, so that you can blindly return 0. Otherwise, it's time for us to process. Now let's move on. What is our job? So first we will see, as long as your queue is not empty, you need to process it. Okay, so first you will just take minute count. So minute count initially, which is 0. Now first you are trying to process, right? So for the first level, so you just need to roten all the connected oranges, so that you just increment minute count plus plus. So somewhere once you process this level, all the connected fresh oranges will get roten, so you will just increment that count. So what is our job? So first, I already told you, right? So you keep on adding elements to the same queue, so that first you take current level size. So in the current level, what are the how many elements are there, how many rotten oranges there? So only process those rotten oranges, because to the same queue you keep on adding next level elements. So that first you take the current level size and process this level only, so that you can say count starting from 1, count less than or equal to this current level size, count plus plus. Is this clear? This is very important. Is this clear? Line number 24 and 25. Maithili, Kalyan. It's not clear. So what are we doing here? If you closely see, let's say you have input 211, 110, and 011, right? So in this case, first what will happen? Initial process, you get only 00 to the queue, right? So this queue contains only 00, and there are fresh oranges of size 6. Now when you process this, right, you need to process only this one, right? You need to process only this one. So when you process this, to the same queue you will add next two elements, right? So this one and this one. So what is those elements? One is 0 comma 1, other is 1 comma 0, right? So you process
Yes.
these two elements. So it means to the current minute, only these two will get written, right? Correct? Yes or no?
Yeah.
So it
Yes.
means you need to process this level. So once you pop this element, you process this cell, then to the same queue you are adding the elements, right? To the level 2 you will have two elements. Okay, so to the level 1 you will have one element, to the level 2 you have two elements. So you need to process only these two elements. Now if you closely see 0 1, so okay, this is 0 1, okay, sorry, this is 0 1, right? What is it? 0 1, yeah, this is 0 1. So now you see 0 1, so this 0 1 will add up this this one and this one, so that this will become rodent. So it is going to be, what is it, 0 comma 2
One comma
1 comma 1.
one
And
comma.
this 1 comma 0 doesn't add anything because it is already rodent, so that it doesn't add anything. So you see, for so this is level 3. So for level 3 you have again two elements to process. Now when you move on further, so 0 2, right? So you have 0 2. Where is 0 2? So this is 0 2. So there are no elements to process because all becomes 2 here. uh, Now this will pop and it doesn't add anything, but when it comes to 1 comma 1, so this is 1 comma 1, so 1 comma 1,
Will
uh,
add two
so
comma zero.
so it is 2 comma 1, right? So it will add 2 comma 1. Okay, so it will add 2 comma 1. So now this is for level 4. Now for level 4 you need to process only this element. So once you process this element, it will just process this one. What is this? 2 comma
Two
2.
comma two.
So this is level 5. So when you process level 5, this 2 comma 2 doesn't connect anything, so that your queue becomes empty. And what is your job? So for each level you increment the minute, right? So here it is 1, here it becomes 2, and here it becomes 3, and here it becomes 4. So we just need to return that minute count. uh, that's it. So let's see. I think minute count may come one extra, so we will handle that. So that's what I'm saying. So you take the current queue level size and process only those elements from the queue. So you will get a cell, right? So cell from queue dot pool. So you will get a cell. So you will get a row here, cell of 0, and column cell of 1, right? So there are four directions now. Let me copy that code. So there are four directions, right? So hope you are able to understand this.
Yes.
Is that these directions are clear, Maithili, for you? This is for right. So to the same row, you are adding +1 to the column. This is for left. To the same row, -1 to the column. This is for down. This is for top. Is this clear, Maithili? Directions.
Yeah.
Okay. So what you do, you get a row and column, right? So now we need to find out directed row and directed column for that. So obviously you will have directions. From directions you pick up it. It's going too long. Okay. So this is my directed row. So what do you say to the same row? On this directed row 0, and this is my directed column. To the same column you just add directed column. So it means in this case, this first is representing row direction, second is representing column direction. 0 1 means there is no change in row, but there is a change in column, so it will move on to the right. So that's it. So that's how, similarly, right left, so you'll get all these directions. Now it's time for you to check that validate condition. So if directed row goes less than 0, or directed column goes less than 0, or if directed row is equivalent to row size, which is m, and if directed column, which is equivalent to column size, which is n, or if it is not fresh orange. So you can simply say if it is not fresh orange. So how do you say that? If grid of row column is not equal to 1, then this is not valid, so that you can simply continue. Otherwise it's a fresh orange, so that mark this as row 10. Okay, so fine. So you can mark it as roten. So you can make it as 2. And similarly, you have marked the current as roten. So that just make sure that you just update the fresh orange count. Then you have taken the current grid, right? Current cell, right? Add the current cell to the queue so that it will be processed in the next level.
Shrinu, that should be grid of directly
Yeah,
row
yeah,
and
yeah, yeah, yeah. Thanks. Yeah, it's a directed row, directed column. Directed column. Yeah. That's it. So this will process everything. So what is our job? So you see, for every level, so once you process the current level, you are just incrementing the minute. So finally, what is our job? So finally, we will check this fresh orange count, right? So if fresh orange count is equal to 0, then we can return this minute count. Otherwise, you can return -1. Clear? Logic is clear, Maithili Kalyan.
mm,
Let me run
Yes.
it. Counter spelling is wrong. Okay. It is count. Yeah, it is adding +1, right? So let's see what is that +1. We can,
so sometimes we need to adjust
yeah, that we need to
minute
adjust
count.
because for the last level also it is adding, right? When do you adjust that? Okay, so
When adding to the
I
queue,
think
it should be
no,
at zero.
it is not like minute count -1, but there is a tricky part.
no, we should only add and after
If
Q
there
dot
is any
add, right?
orange roten, right? Correct? In the current level, this is a current level, na? Within this current level, if there is any orange gets into, if there is any fresh orange gets into roten, then only you will increment the minute count, right? Yes or no?
Yes.
Do you understand what I'm trying to say? Let's say, let's say this is the critical case. Let's say you have, oh my god. So you have 2, 1, 2, 2, 2, 2. Okay, so this is the input. Okay, so this is the input. So you will add this. So initially you start from here, right? So let's say all are zeros. Let's say all are zeros for clarity's sake. So initially you are at 0, 0, and you are adding what is it? 0 comma 1. How are you adding 0 comma 1? Because it is fresh orange, so that you update it to roten, so that it take 1 minute, right? Now when you process 0, 1, do you find any orange to roten? When you process 0, 1, do you find any oranges to roten?
No.
No, 0, 1, right? From 0, 1, is there any all are empty oranges? There is no fresh oranges to roten, right? Correct, no?
Yes.
It means at this point in time I should not increment the minute, right? So when I process this, obviously your queue becomes empty, but I should not increment the minute, right? Correct, na? Why? Because when I process 0 comma 1, when I process 0, 0, and I found one fresh orange which is getting to row 10, that's why I calculated as minute 1. But when I process 0, 1, and when I connect 4 directionally, I couldn't find any fresh orange, so that I got empty list here. And also I didn't update any roten orange, any orange to, I didn't made any orange, any fresh orange to roten. So obviously this should not be updated, right? Yes or no?
Sir.
Maithili, is it confusing?
Mm.
So my point is this. So actually we have started from. There are two ways to address that issue.
So you are saying once so we have to check for the neighboring cells, and if there are no oranges to rot, then we no need to increment the minute count.
Yes, on that level, on that complete level.
Oh, for that iteration, okay.
Yeah, on that complete level. Not only in this case, in the 0, 0. So once you find only one roten orange, so that
Mm.
it is 0, 1. But you may find, for example, you have one more here. You have one more here, so that you found two rotten oranges, right? So
Yeah.
one is at 0 1, other is at 1 comma 0, right? Now when you process this level, do you find any fresh orange? You don't find any fresh orange, right? For 0 1, do you find any fresh orange to rotten?
No.
No.
For 1 0, do you find any fresh orange to rotten? It
No.
means when do you update the minute? If there is any fresh orange gets into rotten, then only you increment the minute, right? Otherwise no increment, no? Correct?
Correct.
So in this
Yeah.
case it is minute 1 incremented by 1 by minute incremented by 1. And in this case there is no increment on minute because you don't have any fresh oranges to process, right? How do
Hmm.
you find that? How do you find that in this logic?
Maybe we can have one boolean if
Perfect. Yeah.
for every iteration.
Yeah, so in this case, before processing the level, what you do, you will have boolean is fresh orange
Is rotten. No, is fresh
found.
orange.
You
Okay.
can say found. It as false. If you get here, it means you found a fresh orange, right? Correct, na?
Yes.
So then, if it is fresh orange found, and you can just increment the minute. That's it. I think.
Hmm.
So that's how it works. So down the line you may have lot of elements, it doesn't route anything. So that's how it works. 100% submission. What is the time complexity? What is the time complexity?
It's M by N.
MN only, na? Maithili? Is it any confusion?
No, before I told
Huh?
Kalyan told.
The
Before I told Kalyan told. So I'm
you
good.
can evaluate, yeah.
Okay. So what is
No,
the
we
space
talked
complexity
with
here?
Kalyan. We are good at complexities.
So what is the space complexity?
He will tell.
No, you tell na.
Sorry. Queue size, right? So we are maintaining a queue. I think
Hmm. It's again
for
one.
every iteration should we count, no? MN only.
Mn. So in worst case on Q you have mn by two elements, then it is mn. Okay, as this is the first problems on BFS, right? Uh, you may feel little hard, but if you practice, then it will be very smooth. How is it, Kalyan? Do you understand correctly? I think Maithili got the idea, but she needs some practice.
Yeah,
No.
to revisit it again. Understood the whole idea. The implementation bit.
Yeah, implementation bit confusing. Okay. Are take pen and paper and do it.
Sure.
Yeah. Okay. Let me stop recording.